In this assignment, you will apply the roof object to the building information model. In order to apply the roof object, we will need to first identify the components that make up the roof object. In this detailed drawing here, the structural or the framing member for the roof is called a rafter. In this model, the rafter is made of a 2x4 dimensional lumber. In a building, the rafters are spaced apart either 16 inches on center or 24 inches on center. This means from the center of one rafter to the center of the next will be either 16 inches or 24 inches. In the building information model, in the project browser, so to activate the finished floor 1, you will double click on finished floor 1 in the floor plan views. You will need to select the architecture tab. In the build panel of the architecture tab, you will select roof. In the properties, you will select the edit type button. In the Type Properties dialog box, you will select the Duplicate button. You will name this roof object Roof and click OK. For the structure, we will edit the structure of this roof by selecting the Edit button. For layer number 2, the structural member of the roof will be the rafter. So in the Materials section, we will select the Ellipse button. In the Material browser, we will select Wood for the project material. In the options, we will select Structure, Wood Joist, Rafter Layer. We will select the OK button. The rafter is made of a 2x4 dimensional lumber. Since the rafter is made of 2x4 dimensional lumber, the thickness for this rafter will be 3.5 inches. So we will enter 3.5 inches, which represents the width of the 2x4, and press enter. The sheathing is attached to the 2x4 rafter for the roof. The sheathing or the decking for the roof provides the surface to which other roof components are attached. The sheathing or the decking is made of 4 foot wide by 8 foot long sheets of plywood. Here is an example of the sheathing being nailed to the rafters. So in the assembly of the roof object, the next component that needs to be added is the sheathing. So you will select layer 2 in the Edit Assembly and click on the Insert button. This will give you the opportunity to add another component to the roof object. We will change the function of layer 2, we will change it from structure to substrate. The material, we will change the material to, so we will select wood sheathing plywood and click on OK. We know that the sheathing is made of plywood according to the construction documents here. The thickness of the plywood is 15/32 of an inch. So in the edit assembly, beside the layer 2, we will change the thickness to say 15/32 or 15/32 of an inch and press enter. Attached to the sheathing is the asphalt felt, or the moisture. Attached to the sheathing is the asphalt felt or building paper. The building paper covers the plywood sheathing. The asphalt felt serves as a moisture barrier to protect the sheathing. To add the paper, you will select layer 1 in the edit assembly and click on the insert button. You will change the function of the new layer 1 to membrane layer. Since the paper serves as a moisture barrier, we will select the function of membrane layer. The material will be changed to paper. So we will select the paper material and click on OK. We will leave the thickness of the paper at 0 inches. The finished material for the roof object are the shingles. The shingles are applied after the building paper has been attached to cover the sheathing. To add the shingles, you will select layer 1 in the edit assembly and select insert. You will change the function of the new layer 1 to finish 2. You will change the material to asphalt shingles and click on OK. The thickness for the shingles will be 1/4 of an inch and press enter. So in the edit assembly for the roof, you should have layer 1 as your asphalt shingles that are 1/4 of an inch thick. That will have a function of finish 2. The second layer will be your membrane layer, which will be the asphalt felt paper that is 0 inches thick. Your third layer should be the core boundary. Your fourth layer should be the plywood sheathing, which is a function of substrate, and it has a thickness of 15/32 of an inch. The fifth layer should be your framing or structural member, which is the wood rafter. Since it is made of a 2x4, the thickness will be 3.5 inches. And the sixth layer should be your core boundary. Your framing member and the sheathing should be between the core boundary. In the Edit Assembly dialog box, you will click on OK. In the Type Properties, you will select OK. In the Properties, to set the base level to Finished Ceiling 1. In the ribbon, you should see a draw panel. you will select the down arrow in the draw panel and you will select the pick walls option. The layout of the roof will be determined by walls. For the overhang, you want to change this to 1 foot. The information about the overhang can be found in this detail view here. The overhang is the distance between the exterior wall and the edge of the roof. In this model, the overhang for the roof will be 12 inches or 1 foot. So here we will need to make sure we change the overhang to 1 foot. We'll bring our cursor into the drawing area and select the exterior walls. So we will click on each of the exterior walls, and that will create the layout or the footprint for the roof object. In the layout of the roof, we will also need to determine the slope or the pitch. You will notice that the roof slopes toward the front of the house and toward the rear of the house. This is shown in the left and the right elevation. The roof slopes toward the rear of the house and the front. The roof does not slope on this side, nor does it slope on this side. This is what is called a gable roof. The slope or the pitch of the roof is the roof's angle. The pitch is indicated by 2 numbers separated by a colon. The first number is the rise of the roof, and the second number is the run. In this example, the roof has a 412 pitch. This means for every 12 inches the roof is long horizontally, it goes up vertically 4 inches. You will select the left vertical line and you will take the check out of the box that says defines slope. The left side of the roof does not slope, so we will take the check out of the box saying defines slope. We will do the same thing for the vertical line to the right of the roof layout. You will select that and remove the check beside defines slope. This will make sure that the roof does not slope left to right. You will need to make sure that the slope indicator or the slope symbol is on the line that is to the top, as well as the line that's to the bottom of the roof layout. After identifying the sides of the roof that slope, we will also need to make sure we put in the slope dimension. The slope dimension can be found in the right elevation as well as in the left elevation. It can also be found in the eave detail. The slope of the roof for this project will be 4/12. So to change the slope of the roof, one way you can do this is to select the line at the bottom of the roof layout. You should see the slope of the roof show up here. Right now it is 9/12. We need to change that to say 4/12. So you can select the number 9. That will allow you to edit this value and change it to say 4 inches over 12 inches and press enter. Another way you can do this is if you select the line at the top for the roof layout, you will see the same indicator. You can change this in the properties dialog box. Right now it says 9 inches over 12 inches. You can change the value of the 9 here to 4 and press enter and click on apply. This will change the roof pitch or the roof slope to 4 over 12, which is indicated by the drawing. After setting the overhang and the slope or the pitch of the roof in your ribbon, you should see a mode that has a green check and a red X. After you have established the overhang and the slope for the roof, you want to click on the green check. What you may notice is that the roof disappears. What you can do is go to your View tab and select 3D View in your Create panel of the ribbon. This will allow you to see the roof in the 3D view. You will notice that the walls on this side as well as on the opposite side do not go all the way up to the top of the roof as they should. The way you can fix that is select the wall. In your ribbon you should have an option that says attach top base. You want to click on that option and then click on the roof. What should happen is the wall should now go up to the bottom of the roof. You can do the same thing on the other side by selecting the wall. Where it says modify wall in that panel of the ribbon, you want to select the one that says attach top base. Click on that and click on the roof. That will allow the wall to go up to the roof. You now have added the roof object to your building information model.